Hello, and welcome to 5 Minute Math. Today we are looking at the fifth grade concept of classifying 2D shapes. This is 5.5a Readiness Practice, the intermediate version. If you're interested in exploring the proficient or advanced versions of 5.5a or the Readiness Practice resource along with any other standard, you can find those by using the link in the video description. So we've got a Venn diagram here, and we need to find a shape that goes just on the left, a shape that just goes just on the right, and then a shape that goes in the middle. Let me zoom in a little bit here, and so we can see this a little bit better. All right, so we need a parallelogram. So a parallelogram is what do we know about that? It's got four sides, means it's a quadrilateral, and it's got two pairs of parallel lines. So I'm going to use these. The geometric representation for parallel looks like two lowercase l's, two pairs of parallel lines. All right, so what kind of shape can we put here that's got four right angles? Well, that I can actually kind of cheat and I can draw. Now let's get that into the correct color. I could draw a rectangle right there. And so a rectangle is a parallelogram. It's got two pairs of parallel sides, and it's got these four square corners, but they're not equal. And so if they were equal, I'd have to put it in the middle. So this is my rectangle. Now I need to have a four-sided shape that is equal, but not necessarily with four right angles. That's going to go in the middle. So I'm going to draw, and I'll try my hardest to draw it without using, the straight lines. And it's going to be that. And so this is supposed to be a rhombus. A rhombus has four equal sides. Okay, so a rhombus could work there. So then what could I draw that has four right angles and four equal sides? Well, you probably have already thought of it. See if I can get it to look exactly right. That is going to be my square. It's got four right angles. It's got four equal sides. It's like a square, and it's like a rhombus and a rectangle put together. That's going to be a parallelogram with four right angles and four equal sides. For our next problem, we've got a situation here. Miss Lee asked her students to create a Venn diagram to show the relationship between isosceles and equilateral triangles. And we've got three students, Shemaya, Tasha, and Zoe, have all tried to draw a Venn diagram, and only one of them is really correct. So let's zoom in a little bit here. Isosceles triangles. Okay, so isosceles triangles have at least two equal sides. And then equilateral triangles have, since we're talking about sides, three equal sides. All right, so here's an example of an isosceles triangle. All right, let me see if I can get a shape for that. So yeah, so this would be an isosceles triangle like this. It's got two equal sides, and then an equilateral triangle, right? I could draw one, and I'll do it a little bit smaller, and it's going to be kind of like this. It's all meant to be exactly the same, like that, okay? Now, here's the thing. You notice that I said at least two equal sides. So, which of these three is going to be correct? Well, if I have an equilateral triangle, so let me take my equilateral triangle. Let's see if I can get that. What if I were to, let me see if I can grab this, and I want to copy it, and I want to paste it. I want to bring it right down here. All right, so there's my equilateral triangle. I'm looking at the one that Zoe has right there. Does that equilateral triangle have at least two equal sides? Yes, it does. So that means that Zoe is correct. And we'll say Zoe is correct. Because even though we think of them as two different types of triangles, look at the definition. At least two equal sides. And an equilateral has at least two equal sides. It has three to be exact. So all equilateral triangles are isosceles triangles because they have at least two equal sides. They just happen to have three equal sides. So it's not going to be necessarily Shemaya because you can't have an equilateral triangle that's not also an isosceles triangle. It's not going to be Tasha because that's where they don't even intersect. You would have the equilateral triangle inside your isosceles triangle. All right, so Julie is drawing triangles and placing them in each column. Are there any columns in which no triangles fit? If so, which ones? Okay, so triangles, can I draw triangles with parallel lines? All right, so parallel lines look like this. Can I make that into a triangle? No. The closest I can do is I can make that into a rectangle. That's as most as I can get. Okay, so I'm going to put a big X here. There's nothing there. Now, what if I did perpendicular lines? Now, perpendicular lines are when you have one that's straight across, one that's straight down. I'll have it open like this. Can I turn this into triangle? Yes, I can. Look, I can make a right triangle like this, and those are perpendicular sides. So I'm going to say a right triangle. And then congruent means equal. Well, we already looked at that. We already looked at a triangle that is equal. Let me see if I can get it to be right at 60. All the angles are right around 60. It's got to be as close as we can get. We can say equilateral triangle. All right, so there are no triangles with parallel lines. So we can make that as our answer that we can write. We can say there are no triangles with parallel lines. So that does not work. But you can make triangles with congruent sides. You can make triangles with perpendicular lines. If you are interested in exploring the 5.5a Readiness Practice resource for the proficient or advanced version, or the Readiness Practice resource along with any other standard, you can find those by using the link in the video description.